Thank you for the introduction. My name is Eyob Mengiste. I am an instructor and PhD student at New York University in Abu Dhabi. I am presenting this work on behalf of my co-authors, Dr. Prieto, Mr. Menon, and Professor Garcia Soto. The research that I'll be presenting to you today is trends of point cloud segmentation in construction research. Before we go deep, we know point cloud segmentation is just a subdivision of point clouds into useful clusters that are easy to manage and to give meanings. It gives us a lot of advantages, including enhancing accuracy, improving efficiency in terms of time and in terms of cost, and also it gives us better collaboration. In this research, we would like to address these questions, the first one being, we wanted to identify what kind of techniques are being used in construction industry to segment point clouds. And also we want to compare that with the techniques that are being used in a non-construction related research. We wanted to also see the common metrics that are being used in this research to measure the efficiency of segmentation processes. And the last but the important one is to understand the common challenges that are facing in the construction related research to adapt methods that are being developed in non-construction related research. So to do this research, we explored a lot of publications. Of course, we extracted this publication using keywords. We subdivided these keywords into 3 different categories. The first one is the traditional. It is subcategorized into these 3 main parts, which are supervoxel based, region growing based, or model fitting based techniques. Each one of them are attached with several algorithms, approaches, and techniques, as you can see on the screen. And the second one is machine learning. There are 2, we classify this into 2. The first one is unsupervised, and the second shallow learning. Again, these are also attached with several other techniques. The last one is a deep learning, and in there we have point-based, projection-based, and discretization-based. Several methods, algorithms are also available in here. So the publications that we have extracted are laid down like this across the categories. In the construction research, we found out around 750 publications, and then in non-construction, we found something more than 4,890. As you can see, the major or a bigger number is seen in subcategory 1.3, which is model fitting based techniques. And the second big is in a shallow learning techniques. But this could be an accumulation throughout the year. So we wanted to do some sort of a timeline and see which one has been there from the beginning and which one is increasing throughout. So within this timeline, as you can see, this shows the non-construction based non-construction research up to 2022. As you can see, in the most recent years, we see that the heavy adaptation or consideration of deep learning-based method, specifically point-based method, followed by machine learning, which is a shallow learning-based methods. Until 2018, however, we see there is a very big dominance of model fitting techniques, which makes sense because model fitting techniques has been around for several decades. In comparison with the construction research, as you can see, beginning from 2018 or from the beginning of this research time up till now, we see a very big popularity and dominance of this model fitting techniques. And there is a little bit of consumption or popularity in recent years, specifically in this shallow learning-based methods and deep learning-based methods, which is point cloud. Now, from this timeline, we see that in recent years, we understand there is a big appetite for deep learning methods. So we wanted to see closely into these deep learning methods. So we did this evaluation. So in non-construction techniques, the most popular techniques that we see are PointNet and PointNet++. Both of them are point-based techniques, and they account for almost 3/4 of the circle. And in comparison with the construction publication, we see the point-based techniques account for almost half of it. And we see a little bit heavier adaptation of a dynamic graph CNN methodology. When we come to the metrics, we see the non-construction-based publications rely on accuracy and a little bit of intersection over union. But in the construction sector, we see accuracy being used a little bit, mostly in addition to the other metrics. but there is a heavy consumption of intersection over union. At last, we wanted to compare what are the main challenges that we can actually accumulate from all this review that we did. We kind of categorize the challenges into 4. The first one is a point cloud quality based, and complex geometry, data availability, and limited automation. When we go to point cloud quality, we know in the construction site, it's not really easy to get a uniform point density across the environment. So segmentation is somehow dependent on point cloud density. So not having that kind of affects the adaptation of non-construction based techniques in construction. And moreover, it is very common to get a lot of noise and also occlusion in the construction based on point clouds that are taken from the construction site. So this kind of hinders or limits the application of methods that are developed in non-construction research. The other one is a complex geometry. We all know that a construction site is a dynamic environment that could actually give us a lot of complexities in shapes. Usually, construction sites have a lot of clutters, unfinished elements, sometimes formworks. All of these things are not really defined shapes, so it's not really easy to segment elements out using the methods that are developed in non-construction based methods. The last one, the next one is data availability. I mean, it is common practice as well in construction, developing algorithms using synthetic data. Again, in the non-construction based non-construction research, we see a lot of adaptations of this synthetic data, so it's not really easy to bring them down to the construction research. The last one is limited automation. And in construction, we see we need a lot of automation because it's really expensive, and also it involves a lot of point clouds. So automation is somehow very required in this process. At the end, in conclusion, we see a very heavy popularity of deep learning techniques in non-construction applications, but in construction-related applications, we see a shallow learning and fitting-based techniques being used a lot. As a limitation, this literature review is heavily used in keywords and evaluation of abstracts. So in the future, we look forward to do in-depth analysis of the papers themselves and somehow do some comparison between the methodologies. So thank you for your attention.